In this lesson, we will study the definition of infinite sequence. An infinite sequence, and usually we denote it as AN, and it usually starts at n equals 1 all the way to infinity. It's the order list of numbers of the form, so you have to list them out. It's A1, A2, A3, and so on. And you might want to write AN, which will give you a general formula if it's known or if there's a rule, and it continues. And a common sequence that we will deal with, you might have learned of it in pre-calculus, arithmetic sequence. And basically, arithmetic sequence is that the nth term subtract the previous term will give you the same difference. And this is true for the entire sequence. And another sequence that we might have encountered in pre-calculus is the geometric sequence. And the nth term divided by the term before it will give you the same ratio. And these two sequences are nice in a sense that we do have a formula for AN. Now, assuming it starts as at A1, okay, so the formula for AN will equals, for arithmetic function, A1 plus n minus 1 times d. And for a geometric sequence, also assume it starts with A1 is AN equals A1 times R to the n minus 1 power. Now that's why sometimes you will see some sequence begin with A0, okay? You can choose a starting point, or the question can choose any starting point. And the only difference is that the rule will be the same, but you adjust the general formula for AN. AN in this case will equals A0 plus n times d, and that's why some people would prefer start with A0 because AN will correspond to n times d. Similarly, AN for geometric sequence will equals A0 times R to the nth power. Okay, so these are just minor difference. The more you study and encounter this sequence, the easier it is for you to understand the difference of this just slight difference of the general formula. There are many other sequences that doesn't have a closed algebraic expression, which we will study later in some of the example. But for now, we can take a look at example 5.2 from the textbook. So for part A, it's given to us that A1 equals 2, AN equals minus 3, AN minus 1 for n greater than or equals to 2. So we can take notes that, okay, so note, we want to find a relationship, okay, of AN and AN minus 1. We kind of know that it's a multiple. So when we divide both sides by A sub n minus 1, we get negative 3. And we will know immediately that this is a geometric sequence. And this realization will help us to apply the general formula. So an will equals, and we notice it begin with a1, okay, a sub 1. So we'll use the yellow formula. So a sub 1, which is 2, times the ratio, which is -3, and then to the n minus 1 power. So if we have the formula, we can skip what you see from the textbook, that the calculation of A2, A3, and A4, and so on, to realize a general pattern. So for part B, okay, similarly it's given A1 equals 1/2, A sub n equals A sub n minus 1 plus 1/2 to the nth power. Now, we would think about this. What kind of sequence is this? Do we have, so when we do A sub n subtract A sub n minus 1, we will get 1/2 to the nth power. It is not a fixed number d. So d is always fixed, meaning it will be 1, it will be 2, but it cannot be 1/2 raised to the nth power. So in that sense, it's not a arithmetic sequence. And similarly, if you do an divided by a sub n minus 1, you don't get a ratio. So it's not a geometric sequence or arithmetic sequence. And we will need to eyeball, okay, we will need to be able to see what the general formula is going to look like. So we will write out a few terms, like the textbook will give us. A1 is 1/2, A2 is 1/2 plus 1/2 square, A3 is, so when you calculate A2, you get 3/4, so you get 3/4 plus 1/2 to the third power, and if you calculate that, you get 7/8, and so on. So, oh, maybe I can write one more. Okay, A4 equals 7/8 plus 1/2 to the 4th power, and is 15/16. What do you realize? You realize the relationship between the numerator and the denominator. Okay? The numerator is 1 less than the denominator. Now we know that. Once we know the expression for the denominator, we will be able to write the expression for the numerator. So what is the expression for the denominator? 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 8. And if you take a look at this, it's going to give us a hint, right? The greatest common denominator is always 2 to the nth power. So that will give us an idea, okay, an is, and we figure out the denominator first, okay, 2 to the nth power. So 2 to the 4th power in the bottom. And the numerator, we already know the relationship is 1 less than the denominator. So that will be our formula for an. And you can simplify it if you want. 1 minus 1/2 to the nth power. So this is how you generally find the formula for A sub n, and that is sometimes by knowing geometric or arithmetic sequence formula. Sometimes you need to eyeball and see the patterns, okay? See the pattern.